To reach with one touch the foundations of reality, I reach with mathematics. Mathematics works to describe our world at all levels of the hierarchy of physical existence, from fundamental physics to biological organisms to human systems. What about mathematics itself, pure math? Can we say what math is, not just what math does? Is math intrinsic to existence, the foundational building blocks of all that is? Or is math imposed on existence, a construct of human imagination? To me, in seeking ultimate reality, whether math is intrinsic or imposed makes a big difference. Mathematicians speak about truth and beauty. I like truth and beauty as twin probes of mathematical essence and power. It triggers one of the deepest questions I can imagine. Is mathematical truth and beauty intrinsic or imposed? I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out. To probe truth and beauty, I begin in Los Angeles with a scientific polymath unafraid to challenge conventional science. He wonders what the universe may be about. Theoretical physicist Paul Davies. Paul, how do you look upon math as a window to ultimate truth?
I think of mathematics as the most secure form of human knowledge that we have, because it's based on axioms that we accept as given, and then logical deductions that flow from them, often called theorems. And the whole body of mathematics is this vast and elaborate network of objects and relationships, which are like an iron framework. They are locked together by the nature of axioms and deductions that follow from them, the iron rules of logic. Of course, it came as a great shock when, a little over 100 years ago, it was discovered that there are some statements in mathematics and indeed in logic which are undecidable, can be proved neither true nor false. And so that leads to a whole new way of thinking about the nature of truth in mathematics. As to whether it is invented or discovered, well, mathematicians vary a great deal. I myself have always been inclined to this Platonic view, goes back to Plato, that mathematics is somehow out there. It exists, it is real, it doesn't exist sort of in space and time. So it has a type of transcendent existence, which makes it very fascinating because it doesn't depend on the world. And that raises the whole question about the relationship between mathematics and the world.
When you, as a physicist, look at what pure mathematicians do with number theory, and how do you view that kind of work?
I sympathize with pure mathematicians. I think they're a rather rare breed. They tend to work in isolation, often for many, many years, on a problem that other people would think is rather frivolous. But I can see the intrinsic beauty of that. Mathematics is beautiful. This is a difficult thing for non-mathematicians or non-scientists to accept. It's a mess of symbols. Why is that beautiful? But there is a sort of internal consistency and symmetry and
simplicity.
Simplicity comes a long way, I think, to describing why we would describe things as beautiful. And the thing about mathematics is that it gives you these relationships between things which you may have never suspected are connected. Mm-hmm. And if this can be a streamlined and deep relationship, then that is obviously an aspect of beauty, and this happens all the time.
This is one of the areas that mathematicians love, when they have two completely discrete areas that seem to have nothing to do with one another, and then they find a deep connection. How come the world is organized that way? What does that mean?
Well, when you see it in mathematics, maybe one way of thinking about it is that if you as a metaphor, you view these relationships as like a landscape with a particular shape. Mm-hmm. And then you might have a different landscape over here. You think it's completely different because it's described in a different way by different mathematical objects and so on, but really the shape is the same, that you can fit the one to the other, and they're really saying the same things. And that does happen, and it also often happens in physics.
Physical reality is explained by math, but math is not exhausted by physical reality by no means. Math is vastly more than physical reality, and you still have these deep connections in the pure math. There's got to be meaning to that.
Mathematics is like a vast and wonderful warehouse of objects and relationships. And Mother Nature plucks out a symmetry group here and a differential equation there and so on. One way of thinking about this that we imagine the set of all possible mathematical relationships, which is, of course, infinite, but it's this vast set. And then this tiny, tiny subset, which is the aspects of mathematics which seem to be incorporated in the real world. And if we want to use a sort of theological analogy or description of this, that, God, who of course is a mathematician, will survey this vast warehouse and then decide to have this little subset. Yes, I can make a nice universe with that. And maybe a different universe over here with a different set of mathematical objects and so on. And it's one of the great deep mysteries that many scientists don't even bother to think about, as what is it that delineates that boundary between the set of mathematical objects that exist and the set of mathematical objects that actually apply in the real world. It's a deep mystery. I think we have no understanding of that.
Paul envisions mathematics as descriptions of what, in principle, can exist, only a small subset of which, in actuality, does exist. For describing mathematical beauty, he highlights internal consistency, symmetry, and deep connections. Does this kind of beauty skew toward the intrinsic? Then again, is our kind of beauty species-specific to humans? I should look deeper into a beauty attribute, symmetry. How does it work? Where does it come from? I go to New York to ask a scientist who looks over the horizon and pushes boundaries, theoretical physicist and futurist, Michio Kaku.
Beauty, I think, is symmetry. And things are beautiful because they're symmetrical. Because when you rotate your point of view, you rotate this object, you turn it upside down, it remains the same, like a crystal. That's why crystals are beautiful. So I think that the source of all the beauty in the universe is the Big Bang. The universe existed in perfect symmetry. All the forces, gravity, electricity, magnetism, were all the same as a superforce. There was only one superforce at the beginning of time, but it shattered. It shattered, giving us the broken world of today, remnants of the original beauty of the Big Bang itself. And so the fact that mathematics works is not a mystery to me. The fact that it is beautiful is a mystery until you realize that at the beginning of time, that was the origin of beauty. The origin of the beauty is the Big Bang. That's where this original symmetry came from, and this symmetry is now embodied into much of mathematics today. Now, the critic would say, aha, but there are beautiful theories which are wrong. If this is the set of all beautiful things, then the set of all true things is much smaller. So all true things, I believe, are beautiful, but not all beautiful things are true.
Well, I could argue that and certainly not all beautiful things are true, but I think there are lots of true things that are not beautiful.
No, I think ultimately all truth comes from mathematics, and mathematics in turn is very closely weighted to symmetries. And symmetry, as I said, I think, is the origin of beauty. Now, there is a point of view where things get hazy, gray areas of incompleteness in mathematics, but even in physics, we have incompleteness, which is the uncertainty principle. So yes, I think that things are beautiful because they're true, but I think that there are limits to what we can know about the universe, and that is Gödel's incompleteness theorem and Heisenberg's uncertainty principle.
Michio elevates symmetry as the exemplification of beauty, and also as the original source of beauty, arising in the Big Bang commencement of the universe. But are we conflating our psychological sense of beauty with some set of natural regularities in the laws of physics? Might this suggest that beauty is imposed, not intrinsic? Moreover, just look at the universe today. innumerable objects and actions, all whirling, hurtling, expanding, exploding. Symmetries among rocks in the asteroid belt or among comets in the Oort cloud are not obvious. I happen to think those chaotic structures are beautiful, and they are certainly not symmetrical. Or is it just me imposing my views? Or is there a kind of intrinsic beauty in cosmic chaos? I go to Boston to ask a statistical astrophysicist about the truth and beauty in the data of large-scale cosmic structure. Cosmologist Licia Verde. Your work in cosmology has largely focused on statistical analysis when you're working with disparate data and data points that are dispersed from each other and are going opposite. How do you get truth out of that? And do you consider that beautiful?
Of course it's beautiful. And hopefully there's some truth to it. In the typical example, the typical thermodynamic example where you have a box and you have gas in half of the box, and then you open the division and you expect that the gas will occupy the box uniformly. And you can describe that in terms of probability and statistics. And in the case of looking up at the universe, you are somewhat forced to do that, because we believe that the visible universe is part of a much larger universe, and no theory will tell you, the Earth is going to form there and the Sun is going to form there. What the theory will tell you are the statistical properties of what is in the universe. And therefore, probability and statistic is the right tool to describe what you see and to make inference about the model that generate that distribution.
For example, if you were doing just with population, if you get an average, that's an interesting fact, but sometimes an average can be a distortion.
Yes.
Because if you have two bimodal peaks, and you average them together, you get something in the middle, and it might be no example of anything in the middle.
Exactly. So statistics is a way to compress the information that is there in this vast amount of data, but you have to compress the information in a way that is not completely lossy. So if I only tell you the average, this is a very bad compression of information. I have to tell you something more. I have to tell you the full probability distribution function, and then you know everything. You don't care whether the particular person sits here or there in the distribution. You care on average how many sits here. How many sits.
So really the truth, quote unquote, of probability is really when the ultimate source of data, what is being generated. If that data is just errors around one point that you have a measurement problem, that's one kind of truth.
That's one type of truth. And then with more and more measurement and more data, eventually that will shrink and it will get tighter and tighter. So
but
sometimes
the data itself has
an intrinsic probability distribution. And the information is not on the value. The information is in the entire probability distribution.
And classically, the decay of radioactive elements is in that category.
The large-scale structure in the universe is exactly in that category, because the information comes from the power spectrum. And the power spectrum is what? Is a quantification of the variance, and the variance is nothing but the width of the distribution. So it's not the mean what matters, it's the width of the distribution, it's the uncertainty. The uncertainty is the interesting bit of information.
And that's the real truth.
That's the real truth.
And you can get at it through the mathematical truth of probability.
And that is an insight into the fundamental quantity that describes the model of the universe.
Licia finds truth and beauty in cosmic data, like distributions of galaxies that can be described only by probabilities. We can never predict for sure the specific appearance or actions of any one galaxy, but we can predict with confidence the general appearance and actions of a very large collection of galaxies. So, by using statistics to tease out cosmic structure, do we give a nod to imposing our truth and beauty? I've now encountered three kinds of math. The structures of pure math, as per Paul Davies, the equations of fundamental physics, as per Michio Kaku, The probabilities of cosmic distributions as per Licia Verde. What could this diversity imply about the foundations of math itself? I meet a philosopher of physics known for his work on the foundations of quantum mechanics, David Wallace. David, as a philosopher of physics, you use math all the time. What gives you the confidence that what you're relying upon truly is foundational?
The honest answer would be, I don't really know. The truth of mathematics, what makes mathematical truth reliable, is, I think, one of the deepest unsolved problems in modern philosophy. Mathematics doesn't seem to be something that we just read off the external world, so it doesn't seem to be the kind of thing we can have confidence in from our observations and our senses. And yet, to suppose that mathematics is just logic, just an analysis of what concept follows from what, just seems woefully inadequate to understand the incredible complexities of the mathematical world that we find ourselves discovering. The best I can get at, and it's a bare start, is something like, there's a metaphor that sometimes gets used, the mathematics is a language. That's kind of, I think, exactly right. Mathematics is instead of a language. Language is not a tool that's anything like as suitable for doing science as mathematics is. Mathematics is the framework that lets us understand how structure works. And if you were to ask me for a particular mathematical question, why am I confident of that mathematical question, I could walk you through the reasoning, and the reasoning would be rock solid. When I step back and say, how can I be confident this whole framework works? Do I even understand this whole framework? I have to confess that I do not.
You used a non-neutral term, discover. I might use the term invent. And so how do you distinguish between discovery and invention?
I use discover at least a little advisedly. I don't necessarily want to go all the way to the Platonic picture of mathematical objects out there causally disconnected from the world. In fact, I don't really think mathematics is about objects at all. I think Hilbert had it right. Mathematics is about the way things can be structured, whether those things are the objects in our sights, the objects of our physics. On the other hand, those structures do not simply seem to be our creations. The process of mathematics is a constant series of astonishing results the mathematicians come across. There are facts about the topology of the sphere, the arrangement of the prime numbers, that people simply would not have thought of in advance. The prime numbers, in some way we don't really understand, seem to be randomly distributed, and we know the formula for that random distribution. We know how to study it mathematically with the tools of probability theory. Nobody thought of that. Nobody said, you know what would be great? Let's construct a mathematical system that we can use to count things and that also has prime numbers distributed randomly through it. We found that out. It was amazing. Math is like that day in, day out. So I can't say that we're discovering objects out there. How could we be discovering those? But equally, this isn't simply human creativity at work. This is finding things that no human thought of in the first place.
David asserts that while mathematics requires the most rigor and thus maximizes confidence in the truth of its conjectures, he has doubts about the entire edifice of mathematics itself. Could something be missing here? I have an idea of what some think it could be. I go back to New York to meet a philosopher of mind, language, and metaphysics, educated in pure mathematics and a leader in consciousness studies, David Chalmers. Dave, I want to try to discern the relationship between your views of reality, potential reality, and the nature of mathematics.
Thinking about the old idea that reality is itself a kind of mathematical structure. This goes back to the ancient philosopher Pythagoras, of Pythagoras' theorem, who basically thought that, numbers are the fundamental entities in the universe, and the universe was basically a universe of mathematics. Our best descriptions of reality seem to be in terms of mathematical equations, so it becomes attractive to say the universe is fundamentally mathematical. So at some level, that can't be everything there is to the story. If the universe was just a mathematical structure, every mathematical structure exists, every world exists, science would seem kind of pointless. How is it leading us to one rather than the others? So there has to be something that's somehow more concrete than that, something, if you like, that puts the fire into the equations. And maybe this is a place where consciousness has a role. The other place where consciousness has a role is it seems like consciousness is one thing which is not just mathematics. Maybe we can make sense of the structures out there in the physical world in terms of math. But my consciousness, the reds, the greens, the emotions, the qualities, we can mathematize them, but they seem to have some intrinsic qualities that aren't just mathematics. So that kind of leads to a view where there has to be something sort of underneath that structure, the consciousness. So that can lead one to the panpsychist view of reality. Mathematics tells us how all these fundamental entities relate to each other. But then the question is, what are they in themselves? They need some non-mathematical nature, and a speculation is that might be consciousness. Another approach, which doesn't give consciousness as central a role, is the idea of the it from bit universe. That at the fundamental level, there are just bits of information, and then there are laws that process them, and ultimately these bits give rise to the physical world that maybe gives rise to consciousness. But I guess the world is not pure mathematics on this view. The world is, if you like, applied mathematics. The bits still need to be put into motion. Right. Somehow, some bits of mathematics got selected as the ones that govern our world. And I find that it from bit view very attractive, at least as a view of the physical world, although how it accommodates the human mind is harder for me to see.
Idealism posits that at its fundamental level is a kind of mind or consciousness, and then somehow the physical world is derived from that. Assume that to be the case. What is the role of mathematics? Because if consciousness, which is non-mathematical, potentially, that would make mathematical non-fundamental if we have a pure idealism as fundamental reality.
It's an interesting question whether idealism explains, say, the physical world in terms of the mind. Does it also explain mathematics in terms of the mind? A very strong form of idealism says, yeah, mathematics too is all in the mind. I have to say that even though I've got sympathy for idealism, I find that view very hard to stomach. The idea that 2 + 2 = 4 somehow derives from someone's consciousness in terms of the human mind.
So at least at this point, if you're going to go to idealism, you have a parallel source of fundamental reality, which is mathematics and maybe other abstract objects, who knows, but certainly mathematics. So you're a dualist. If you're an idealist, you're a dualist idealist.
I guess that's right. We got the abstract world, the world of mathematics. We got the concrete world, the world of physics. And maybe I'm more sympathetic with idealism about the concrete world being grounded in the mind, but somehow the fundamental level of the physical world and mathematics have to come together because physics is itself mathematical. So if you're an idealist, then maybe somehow the mathematics plays that role of structuring the mental structures into the laws of physics, the familiar dynamics that we get from physics. So somehow maybe on this metaphysics, mathematics and mind come together dualistically, as you say, to generate reality.
Is mathematical truth and beauty intrinsic or imposed? The conundrum affects the foundations of reality, ultimate reality. To review, math has special claims on knowledge. Symmetries are beauty. Statistical distributions are beauty. The whole framework of mathematics remains a mystery. Could consciousness mean reality is not entirely mathematical? I can make a case for either side. Math is intrinsic, supported by math as mind-independent, reinforced by iron rules of logic. Deep connections between radically different mathematical objects. Math is imposed, supported by different kinds of beauty, uncertainty about math's whole framework. Can we compromise? Math is sometimes intrinsic, sometimes imposed? No. If any of math is intrinsic, then math is intrinsic. Intrinsic allows no compromise. Could consciousness collapse the conundrum? Well, even if consciousness were fundamental, math could still be intrinsic or imposed. Even if God were fundamental, math could still be intrinsic or imposed. While I cannot decide, I can imagine a world of either. A math intrinsic world would have an eternal inviolate foundation. A math imposed world might or might not. Appreciating the difference is closer to truth.
For complete interviews and for further information, please visit closertotruth.com.